Good morning, class. All right, today we're working on SI units, which is our standard unit system of measurements that we use in science. It is similar to metric, but a little bit different. So we'll talk about SI units, what they are, how we use them, and we'll also get into SI unit conversions, so converting between different prefixes within a unit. All right, so let's get moving here. So this is normally a task I would have you do within class. We're going to skip it today because this is not a normal class, obviously, but it is a task or an activity to get you to recognize the importance of units. So the English foot, for one, is not a very good system of units because my foot is different than your foot, which is different than the king's foot, which is different than a baby's foot. So they obviously have standardized that since then, but we can do better than that. And our version of better than that is SI units. So it is the internationally agreed upon standard of units that we use in science. So one thing to note here, SI, not IS. The only reason for that is the group that oversees this system of units uses French as their official language, so it's System International of Units, not International System of Units. But either way, SI units are what we use in science. So there are 7 base units. 6 of them I labeled here today. So the 7th one would be the mole. But that's more of a science term, a chemistry term, and I'm sure you've talked about that already. So there are 7 base units that we are going to use in SI units. So that means that every unit that you can possibly have in physics will be based off of these 7 units. Now there are additional units to these base units. So a good one would be the unit for force. In English units, you'd use pounds. In SI units, we're going to use newtons. But I just said that there's only these base units. Well, there are base units, which you see here, and then there are derived units. So these are derived units, they're called. And all derived units are based off of base units. So for a newton, which is capital N, that is technically a kilogram meter per second squared. So force equals mass times acceleration. Here you have mass, and here you have the unit for acceleration, meters per second squared. So we'll see that a little bit later as we get into the year. But a force unit is a newton or a kilogram meter per second squared. Now, somewhere along the line, somebody said, I pushed on that box with 12.2 kilogram meters per second squareds, and that was annoying. So they changed that to I pushed on that box with 12 newtons of force. So that's what a derived unit is. It's just a simplification of a whole mess of units. Newton is one of those derived units. And we'll see a bunch of those throughout the year. But for our base units, we have a meter, a kilogram, seconds for time. Here's one difference between metric units, Kelvin for temperature, ampere, and that will be electric current, and candela, which is the brightness of a light. So we won't get into that much. Maybe a little bit with electricity unit when we're talking about light bulbs being 100-watt light bulbs and having different brightnesses, different luminous intensities. But the couple of things I want to highlight here. First one, some of these are lowercase, and some of these are uppercase. So Kelvin, ampere, Newton, all uppercase. So why is that? Well, the reason is Newton is a person, right? This derived unit was named after Sir Isaac Newton. So he is a person, so therefore his unit is a proper noun, just like his name is a proper noun, so it gets a capital N. And therefore the unit gets a capital N as well. So that means Kelvin was a person, and he's a dude that did a bunch of experiments with temperature and energy. So capital K. Ampere was a person, so capital A. Candela was not, so lowercase c. Lowercase s. There's no person named second. Another weird thing here, kilogram. You now see here's your unit and here is your prefix. This is the only base unit that has a prefix. Candela, CD stands for candela. There's no prefix on that one. So kilogram has a prefix in the base unit. For whatever reason, somebody decided that long ago. And that's just what we use now. So just something to get used to there. Kelvin. Why do we have Kelvin instead of degrees Celsius? Well, that one's easy. What does degrees Celsius have that no other system of measurement has? If this is 0 degrees Celsius, and this is 100 degrees Celsius, what is over here? Negatives. Why would we want negatives to be part of our unit of measurement for temperature? That doesn't really make much sense. Now, it made sense as far as building thermometers, but it does not make sense as far as our unit of measurements. So we don't want negatives in here. Negatives in physics generally mean a vector. They give direction to something. We certainly don't have temperature in a direction, so that doesn't make any sense here. So they sought to make a system of units for temperature that didn't have negatives. So in order to not have a negative for temperature, you need to know the coldest temperature it ever could possibly be. And that temperature is absolute zero. So absolute zero is a point in which there is no energy left in an object. That is the coldest it can be because energy is heat, which is temperature. So if there is no energy left in an object, it must be at absolute zero. And that temperature is minus 273 degrees Celsius. It's actually a little bit more than that, minus 273.15, something like that. But we'll call it minus 273. So that means that should be your 0 point. Anything above there is going to have temperature. It's going to have energy within it, heat energy within it, correct? So if that's the coldest it can be, then that will be our 0. So then they went and they just kind of followed this is what makes things kind of easy to convert between degrees Celsius and Kelvin. They follow the same scales. So if you get 1 degree warmer in degrees Celsius, you also get 1 Kelvin warmer. So minus 273 degrees Celsius is the same as 0 Kelvin. That means 0 degrees Celsius would be 273 Kelvin. Now 0 to 100 degrees Celsius, you went up by 100, which means you go up by 100 Kelvin as well. So 373 Kelvin. You can kind of see the pattern here. So that makes converting them pretty easy because you just subtract 273 degrees Celsius or add whichever way you're going. So that's our unit of measurement for temperature, and that makes more sense than degrees Celsius, so we can avoid the negative numbers. All right, moving forward, we're going to look at prefixes. Now, here's the glorious thing about both SI units and metric units. They are based off of a series of factors of 10. So 1 kilometer is 1,000 meters. So 1 decameter is 10 meters. And then there is 1 something that is 100 meters. And then 1 kilometer is 1,000 meters. So you can see there's easy conversion between them because they're all based off of units of 10. Now, it's certainly better than having 1 inch go up 12 inches to go into a foot. And then from 1 foot to a mile would be 5,280 feet in a mile. That makes converting between them difficult. But since everything is based off a factor of 10 here, it will be rather simple. And I'll show you some tricks in order to do that and how we'll do unit conversions throughout the year. So we're going to use a little thing called unit cancellation. All right, let's see how this works. I'm going to start this one up here. Say I have 120 centimeters, and I want to convert that into meters. So our unit is meters, and our prefix is centimeters. And I want to get rid of that prefix. So what if I took 120 centimeters and I multiplied it by 1? Would that change that number? And the answer is, of course not. You multiply anything by 1 and it stays the same number, correct? So let's take that a bit farther. What if I multiplied it not by 1, but by 1 over 1? Again, that number would not change. It would still be 120 centimeters. What if I multiplied it by 10 over 10? 10 over 10 is equivalent to 1. So again, we would not change it. Whatever on the top is equivalent to whatever on bottom, then you're not changing your number. Okay, we're going to use that little trick to convert units. So we're going to take 120 centimeters. We're going to do this thing called an open conversion factor. It's basically a fraction, empty fraction. Now, if we just put the same number on the top and the bottom, we are going to just stay in centimeters. Now, what we want to do is we want the top to equal the bottom always. That's how this works. But as long as the top equals the bottom, they don't have to be the same prefixes. So, for instance, there is 100 centimeters in 1 meter, right? So 100 centimeters is equivalent to 1 meter. So if I had a fraction with 100 centimeters in 1 meter, that would still be equivalent to each other. So we can use that as a conversion factor. It won't change this number. It may, however, change the unit, which is what we're trying to do. So I want to change this unit to meters. And if I want to do that, I'm going to have to cancel out centimeters. So what you generally do is I tell you to put an open conversion factor, put centimeters on the bottom, because that's the thing we want to cancel out, and put meters on the top, because that's what we want to go into. Correct? Now we need to know how many centimeters are in a meter. Now I knew that, so I gave that to you here. But if you do not know that, you get this handy-dandy chart that you can use on any test or quiz. This is on your formula sheet. So the way to look at this chart, if you have 100 centimeters and you want to find the equivalent, actually let's do this a little bit different. I'm going to come back to this one. First I want to do, let's do 4.2 kilometers into meters. Same problem, but we're going to go kilometers to meters. I'll show you why I changed this a little bit. I need to know how many kilometers are in a meter or how many meters are in a kilometer. So I'm going to use this chart to do it. So if I have 1 kilometer, how many meters do I need to have for those two sides to be equivalent, because that's what we need, right? So that's where this chart comes in. So if you have 1 kilometer, what you're going to do is this stays the same, this stays the same, and whatever you see your prefix, this is when you sub in that number from the chart. So if 1 kilometer, we're going to have 1 times 10 to the third from that chart meters. So 1 kilometer equals 1 times 10 to the third meters. So 1 kilometer, just to get it out of scientific notation, equals 1,000 meters. Beautiful. That is the little equivalency that I need to plug into my conversion factor. Okay, so as I said above, I need kilometers to cancel out, so I'm going to put kilometers here. I want to go into meters, so that needs to be on the top. And it turns out for every 1 kilometer, that is equivalent to 1,000 meters. So 1 kilometer is equal to 1,000 meters. So now, kilometers cancels out, meters lives on. So beautiful, this seemingly has worked out. Now we just need to do the math part of it. 4.2 times 1,000 is 4,200, divided by 1 is still 4,200 meters. Beautiful, right? All right, let's go back to this top one. Now this one's a little bit trickier, right? Because if you come to your chart, you're going to have 1 centimeter equals how many meters? So it's going to be 1 times 10 to the minus second meters. So that's still pretty good, right? So 1 centimeters equals 0.01 meters. Beautiful. That will be the conversion factor that we use, and we can come plug it over here. Now, notice this and this look different, but essentially they are the same. If I took both of these numbers and multiplied them by 100, they would be these two numbers. So they are the same, they just look a little different. If you know there's 100 centimeters a meter, by all means use that. But if you're using this chart, you're going to get 1 centimeter to equal 0.01 meters, or 1 times 10 to the negative 2 meters. So this is the information we need to plug into our conversion factor. So where my centimeter is, I have a 1. And where my meter is, I have a 0.01. Beautiful. So 120 times 0.01 is 1.20, divided by 1 is still 1.20 meters. Beautiful. And notice we could have used the other conversion factor here and it would do the same thing, so we'll do that here. 100 centimeters in 1 meter. These cancel, so that's correct. 120 times 1 is 120. Divided by 100 is 1.20 meters. Works either way. Just depends on if you're using this chart or not. All right, let's move on and do a couple examples of these. Can't believe I picked the same numbers that's actually in this. Wow, that is just not good luck. So anyways, 125 centimeters to meter. So we just saw this one, so I'm going to just do it quickly. You write your number, you write an open conversion factor. Whatever unit is here, you are going to put on the bottom. You need those two to cancel out. So this has to cancel out with whatever's on the bottom here. So that's why you put centimeters down here. We're going to meters, so I'll put that on the top. How many centimeters are in a meter? I happen to know that one, so I'm just going to plug that information in. 125 times 1 is 125, divided by 100, 1.25 centimeters cancels and leaves you in meters. Beautiful. Now let's go to this one. This one's certainly different than the other ones. This one's going to be a little bit tricky, right? So first thing you do is you write your number. 2,850, 2,850,000 grams, and we want to go to a megagram. Megagrams are big. Think megabytes. Okay. So gram is here, so gram's going to go down here, and we're going to megagram, so that's going to go up there. How many megagrams are in a gram, or how many grams are in a megagram? That's what we need to find out, right? So come back to our chart. Mega, 10 to the 6. Don't confuse that with milli, which is lowercase m, or micro, which is this Greek mu. We are on mega, which is 10 to the 6. So what that means is 1 gram equals, oh, excuse, I did that incorrectly. 1 megagram is going to equal 1, replace the m with a times 10 to the 6 grams. All right, beautiful. So now I have my little equivalency here. So wherever my gram is, I need 1 times 10 to the 6, which is 1 and 6 zeros. And wherever my megagram is, I just need a 1. Boom. So 2,850,000 times 1 is 2,850,000. Divided by a million is 2.85. And my unit would be megagrams. Beautiful. Final answer. Now, here's where things get a little bit tricky. What if I'm going from centimeters to kilometers? Do you know off the top of your head how many centimeters are in a kilometer? I don't. Nor do I want to know that. What I want to do is convert this from centimeters to kilometers. So there is no, if you go back to your chart, we'll erase this so we can actually see what's going on. Does it tell us how many centimeters are in a kilometer? The answer is no, it really doesn't. So we need to figure that out. So do I know how many centimeters are in a meter? For sure I do. Do I know how many meters are in a kilometer? Yes, I also do. So whenever you have two prefixes, that just means, or you're going between two units of measurement that both have a prefix, I guess is what I'm trying to say, you need to use a two-step conversion method. So we're going to take 174 million centimeters. And I can't go straight to kilometers because I don't know that conversion factor. So what I'm going to do is I'm going to go to meters. Just go to meters first. So I'm going centimeters to meters. Again, I put centimeters down here, so this would cancel out. And I put meters up here because that's what I want to go into. So again, I know that there are 100 centimeters in a meter, so I'm just going to fill that information out. All right, so 174 million times 1 is 174 million. Divided by 100 is 174. I went from 6 zeros down to 4 zeros. 1. So we're not in centimeters anymore. We are in meters. Okay, so now I have 1,740,000 meters. I want to find out how many kilometers that is. So again, new open conversion factor. Meters needs to be canceled, so that will go on the bottom. And kilometers is what I need to go into. So that will go on top. All right, how many meters are in a kilometer? Well, I know that, but let's pretend I don't. So we go to your chart. We find the kilo row, and its kilo is a 10 to the third. Kilo is a 10 to the third. Remember that. So if I have 1 kilometer, that is 1. Replace this with times 10 to the third meters. Beautiful. So now I take that information and I plug it into my chart here. So where the kilometer is, I put a 1. And where the meter is, I do 1 times 10 to the third, which is 1,000. Again, meters is going to cancel. Beautiful. 1,740,000 times 1 is 1,740,000. Divided by 1,000 is 1,740 kilometers is my unit that I'm left in. So beautiful. We did that conversion. We did it in 2 steps. Once you get good at these steps, you'll do them rather quickly. So it's not like it adds all that much time. So one note before I go much further. I know this seems like a bunch of work just to convert within units. But if you follow this method, you'll convert between units quickly and efficiently and accurately. And that's what we're looking for. So a lot of people just are like, centimeters, I'll just divide by 100. Centimeters, I'll just multiply by 100. And unfortunately, when you try to do that, you inevitably get mixed up once in a while. You just do it incorrectly. But when you lay out your conversion factors, it's very hard to mess up because you're going to see if you made a mistake. So use these conversion factors, write them out. It will help you save time in the long run. All right, let's do one more. This will be our last one for today. 2.98 megagrams to kilograms. Again, prefix to prefix. Can't do that. I don't know how many megagrams are in a kilogram. So we're going to have to do this as 2 steps. So I'm going to do something a little bit clever here. I'm going to do it. This was like a fully 2 steps. But I'm just going to kind of do it as one big process. So 2.98 megagrams. Now here I'll convert from megagram to gram, because that's what I'm going to do, right? But after I do that, I'll be in grams. So let's figure out that first. So how many grams are in a megagram? Let's go back to our chart. Mega is 10 to the 6. So what that means is 1 megagram equals, I'm right there. Okay, we'll do it over here. 1, what's happening? Pen decided it suddenly didn't want to work. 2, start this again, I guess. Okay, it's just how it wants me to do it. All right, 2.98 megagrams. And we want to convert that to grams first, correct? So whatever this unit is, we want that to cancel out. So mega, grams goes on the bottom, and we want to go into grams first and then into kilograms. We need to find out how many megagrams are in a gram, and it said 10 to the 6, correct? Let's check that. Mega 10 to the 6. All right, so that means that 1 megagram equals 1 times 10 to the 6 grams. Note, I kept this and I kept this. 1 in grams. And I replaced mega with that number from the chart, times 10 to the 6. Okay, so that gives me the information I need for this. So my mega has a 1 in front of it. My grams has a 1 times 10 to the 6, which is 1,000,000. 1 and 6 zeros. Beautiful. So now I've canceled out of megagrams and I'm now in grams. Now, do I need to do the math out to find out what that is? Not necessarily. So you can just add another conversion factor here if you want. Math doesn't care if you multiply two things at the same time or if you do them individually. So consider yourself in grams now. So now I'm going to go from grams to kilograms. So I want this to cancel out, and I want to go into kilograms. But I need to know, if I have 1 kilogram, how many grams is that? So I go back to my chart. Kilogram, kilo is 10 to the third. Come back here. 1 times 10 to the third gram. All right, great. So where my kilogram is, I put a 1. Where my gram is, I'm doing 1 times 10 to the third, which is 1,000. All right, so now I can go through and do my math. My grams cancel here and here, and I'm left in kilograms. So 2.98 times a million is 2,980,000. Divided by 1 is 2,980,000 still. Times 1 is 2,980,000. And then divided by 1,000 is 2,980,000 down to 2,980. If I did that math correct. Let's check on the old handy dandy calculator because my brain is not functioning at full capacity right now. So 2.98 times a million divided by 1,000. 2,980. All right, did that right. So that is your correct conversion from megagrams to kilograms. Not bad. So today we learned SI units, what the base units are. We also saw a Newton, which would be a derived unit. We learned one-step conversions to convert between different prefixes of a standard of measurement. And then we used two-step conversions to convert between two different prefixes within a standard of measurement. All right, good luck. I'll see you in class.